My name is Anders, and my talk is called Lisp query notation at DSL for data processing. Let's see. Okay, so I'm from Oslo, Norway. I have a background in industrial mathematics and with an emphasis on parallel computing. I have been working as a backend developer primarily, and recently as a data science / data engineer until my company decided to lay off about 10% of everyone, including me. So now I currently don't work anywhere. I hope to do something about that soon. I am one of the hermit Lisp programmers that was mentioned earlier, which makes this a little intimidating because I've been working in my own little box somewhere in Oslo for a while. I think I started using Common Lisp in 2017, and whenever I say Lisp in this talk, that means Common Lisp for me. And I will mention that inconvergent.net is my website, and it's about generative art. It's about programming and DSLs and some of the things that I've made over the years. And I mentioned that here because the reason why I started Common Lisp was that I wanted something new. I was using Python at the time, and I started looking around, and Common Lisp looked really interesting. And I just gave it a try, and I haven't really put it away since. So now I almost exclusively use Common Lisp. I'll try. Okay, so this isn't really. I don't really expect everyone to just throw everything away and start using this tool after this talk. It's more. I hope you'll find it interesting, or if nothing else, maybe you'll find it infuriating, and it'll be a way for you to know how not to design your own little language. I'm sure I'm not the only one in this room who's made multiple small languages of their own. Okay, I won't bother you too much with the generative art stuff, but since that's what was my entry into Lisp, I will say that I enjoy building things from the bottom up. So I built a lot of tools over the years, including a graph database that uses Datalog for queries on these. These are vectors underneath stored in the database, I enjoy sort of experimenting with these things, and one of the things that I enjoy is to sort of know exactly how something works so that I can break it, because that tends to be the process that I use to make art with, which also works quite well with Lisp, I would say. It's easy to break stuff. Some other things that I made recently. There is more stuff like this on my website. If you want to talk to me about this later, or the topic of this talk, please find me. So I wanted to make my own tool for when I make generative art, I need to store stuff, and I started storing things as serialized, so Lisp data, and I wanted to be able to read it back in and process it and do things with it, like drawing with a different set of configurations or something like that. I also just wanted to try to make my own thing because I find it really interesting. And I had a few design principles that I started with, and I also realized when I wrote the paper for this and the talk that I really had to sort of reverse engineer my sensibilities, because it's sometimes when I work on things like this, it feels more like discovering a language rather than designing it. So, but I had some things set down when I started. I wanted it to be terse, short, easy to write on the terminal, There are some things that I've done with quoting and stuff to make it more convenient when you're writing on the Linux terminal. I wanted it to be easy to copy and paste. I wanted my own implementation to be simple so that I could figure out whether this worked for me before I started spending a lot of time optimizing everything. And I wanted it to be a common Lisp library that I could use when I was writing common Lisp, but also something that I could write my own entry points into from the terminal. And we'll see both of those things shortly. Like I said, I don't expect most people here to throw everything away and start using it, but it is on GitHub if you want to look at the code, if you really need a headache someday. Or if you want to take this and use it for yourself, or if you want to just look in the documentation, or yeah, so you can look it up. I said that I worked as a data engineer and data scientist, and we tend to deal with a lot of stuff like this, JSON. I just wanted a simple, small thing that we can use for a few of the examples. So you don't really need to remember this, but just notice that there are 3 objects. They have IDs that are integers, but they are strings in the data structure. And there are also some nesting going on. And we'll see a few ways to deal with these kinds of structures as we go. So it is a library, and it has features that you would expect for loading things. For instance, JSON loadf will load the JSON file. It'll load it into an internal representation, which is Lisp arrays with hash tables generally, because that makes it faster to look stuff up, and it makes it easy to handle. It also makes it easy to have multiple input formats, but they're parsed into this common data structure. As you can see, if you print the value of that variable, you get a vector or an array and some hash tables, and you can see that the count matches the data structure that we saw earlier. I also wanted to have a way to serialize it. I use I don't know how to pronounce this. Yeah, JSON with a Y, the CL library, and this is one of the ways that they use in that library. That's one of the ways you can configure that library to represent this data that we're considering. And so you'll see that if you serialize the data, it's a vector with an A list inside, and then it's nested. Of course, there are many ways you can do this. I've just named mine because I wanted something in the documentation. It's called Lisp notation in the documentation. I know that that's not a thing, but it's just a name that's convenient in the documentation. Okay, let's see how it works. Here, the first operator that we will consider is the get operator, or the at, which does what you would expect. It lets you look up individual things, or like the first one, it looks up the message of the first object, or the second, because it starts with 0. It has default values if you otherwise it will return nil if the thing that you're trying to access is not there. If you use star, you can provided what's at that location is a vector, then it'll return yeah, so it works as a wildcard. So you can look up all the messages on all the objects, for instance, if you see line 5 and 6. Since if maybe you remember that the JSON data structure that we looked on initially didn't have a message on the first object. So if you don't define a default value, you get nothing here. But if you do, it says no. So it returns the value that you input as the default value. And of course, and it also does multiple levels of nesting. I'm sure you can break this. I'm sure I haven't really considered all the alternatives, but this is a convenient start for me at least. And also the keywords that you see here is really to avoid having to escape strings on the terminal, provided that you have keys in your data structures that are lowercase and doesn't include spaces. If you need strings, you can replace the keywords here with strings, and then it'll be case sensitive. Some more operators. The pipe operator, I have never needed to use it myself. It's sort of but it's there. It does, if you're familiar with JQ, which is a programming language for handling JSON, and then it works. It's very heavily inspired by JQ, this thing that I've made, and so the first value or the first thing in the pipe is which I will explain shortly, will be passed to the next thing in the pipe, and the hash parentheses that you see on the first line is actually a map. So it maps the get operator across all rows. So first it finds the ID, the value of the ID, and then it parses it to an integer. And then the second line filters those integers. The brackets is a filter. Excuse me. Did I put my water here? Yeah, so the filter, if you pass bare symbols to the filter, it will evaluate that function or whatever it is with the element of each line in, or each element in the vector as the first parameter. And in this case, the IDs in the object are 1, 2, and 3, and the only one that's even is 2. So that's what you get out. And as I, yeah, of course I did. Sorry. Yeah, as I said, the pipe operator is implicit, so it's not necessary here. It'll automatically pipe that mapped the result of the map to the filter, and so on if there are more things in the expression. Just slightly more complicated expression. It maps, again, it gets the ID, it parses it as an integer, and then it adds 10 to the integer. This underscore is the current value in the map. And then it performs the filter again, but this time it uses an expression instead of just the bare function, the bare keyword, now the bare function. And in this case, it requires that to be less than 13. So again, you get 11 and 12 out. If there are more than one, expressions in the filter, it requires them all to be true. So if you require the value to be even and less than 13, you get the 12 out. And that's not always what you want. And there are modifiers that you can use in many cases for things that at least I find to be things that I do commonly. The question at modifier in front of the less than symbol will they will work as an OR in this case. So it will accept either values that are less than 2 or values that are even. Yeah, so you get 1 and 2. One thing I find that I need frequently is to select everything except something, the negation. So you can use the minus at to drop any value that matches any expression with a minus at operator. So if you have multiple minus at operators inside the same filter, it'll drop any item that matches any of those expressions. So in the first row, you also require the value to be odd, but you don't always have a single condition that you want, so you can use the underscore and it will accept everything instead. Which this to me covers a lot of the cases that you frequently encounter. If it's not satisfied, you can use any common Lisp expression that you want, and the underscore will be the current value. So you can use Boolean operators, for instance. Or you can call your own functions from your own library, provided you have made it available to the runtime. So we'll move to the terminal. You'll see that the language is the same. And I have 3 entry points, JQN, LQN, and TQN. And JQN expects JSON. LQN expects Lisp data, Lisp source code, for instance, and TQN expects just any text file. And you'll just read all the rows into an array. And there are some options for outputting to different formats. So you can, any format or any entry point can output to any format, of course, since it's all represented as the same thing internally. I won't go into the details, but they're available for anyone who wants to see them later. I don't really want to compete with grep. That's kind of a pointless endeavor. But one of the things that I want is to be able to do at least most of my processing inside the same language. So there, you can, of course, filter for, on text. Here we do. You see the modifiers for OR. You see the negation. You see the string version on line 3 where you require the W to be capitalized. Or you can fall back to any kind of expression that you want. In my case, the second row 5 and 6 requires the prefix to be ABC and the suffix of the line to be XYZ. And the I is case insensitive. If you drop the I, the function does the same, but it's case sensitive. And you can use expressions, of course, as we have already seen in the bottom line. You can see that you can do, in this case, it looks into the, I actually think I made a mistake there. I think the size was supposed to look up the, no, this is, oh, excuse me. It looks for short lines, yeah, so it looks for lines that are of a length of less than 3 and that can be parsed as an integer. Initially, I said I don't remember if I said it, but I wanted my operators to be kind of forgiving because it's convenient when you're operating on the terminal to get an output, even if you've typed something incorrectly. And one of the things that you can easily do, at least, is to have some of the operators accept multiple kinds of input, even if it's not necessarily what you want. And map and filter, for instance, will work on hash tables as well. And there is an internal there is a function in the map. The key function that you see on line 6 is provided by the map operator, and it'll provide you with the key, the current key, so you can do things based on that if that's convenient. There's also an iter, which will provide you with the value. There are other selectors. I have we already see in map and filter. I call them selectors. Maybe you'll disagree with that term, but the brace selector does what you will expect. Probably it expects a hash table as an input, and it outputs a hash table. You can select and discard and use the modifiers to drop keys and so on. The hash brace does the same, except it expects an array of hash tables, and it returns an array of hash tables. And the hash bracket does a similar thing, except it always puts the value into an array. So it depends on what your expression does, what the result will contain. Yeah, we already talked about the modifiers. Here are some examples of the brace selector. The most interesting one, perhaps, is this, where we've already seen this, but it's, in my experience, convenient to be able to both modify or drop and add other keys to your objects. Yeah. Yeah, perhaps if anyone has any questions. I wasn't entirely sure how much I would be speaking, or yeah. Yeah, no. Yeah, but finish strong. Yeah, I find this to be a little interesting. It makes it possible to sort of flatten out and destructure things. It selects all the objects, but instead of returning hash tables or dictionaries, it just returns the value of the things that you select. And then we use some of the terminal arguments to, in this case, say output every line in the array individually, don't wrap it in something, and if it's not a string or an integer or something that can be immediately printed, in this case the j in the argument says that it should be serialized as JSON. There are other operators that you'll probably find useful if you were to use anything like this. This does essentially a group by, as you know from SQL. In this case, it groups by the first column of a CSV file, the first part, the hash. The line 2 will split every line on at every comma. So that's, of course, as you know, not a comprehensive CSV parser. That is really something I could use, or I could implement with more time. Yeah. I find this to be quite useful. For me, I find it to be about as terse as I can get it, while still making it possible to use any kind of common Lisp expression that you want as well. I didn't show it to you, but it's quite easy to extend it with other formats. It's not entirely easy to read, especially when typing on the terminal. We don't have highlighting on the parentheses and so on. I'm not entirely certain if I enjoy or if I would like some of the operators to have a different syntax, but I also find it to be quite useful. And if nothing else, it was a really interesting thing to build. So I think that's it.
Right, any questions?
Do you want this?
Just repeat the question.
Okay.
The question would be, do you specify handling of duplicate keys in JSON yet?
If I specify, do I specify the handling of duplicate keys in JSON? I use the library, so that if you yes, there won't be duplicate keys in the output.
Not in the output, but what happens if the input contains duplicate keys? Do you take the first value, the last value, all of them?
That depends on the JSON library I use, and I don't actually know the answer to that. Please.
Yeah, I want to know if you spoke about outputting something how much is being queried. Very often when you query the data and based on the keys or something like that, you take that directly from output, I don't know, maps how about output?
I'm sorry, I don't understand the question.
So let's say you query for a list of integers, but you want to return a map that where you use this integer that's key or some other object. About information, the data is just got from a resource in your query.
I think the hash bracket operator that I didn't really speak about will do that to some extent, or will let you do more creative outputs. I'm not sure if I can accommodate you fully though.
Do you handle message structures like lists?
Yes. All the operators that can be any expression can be an operator in the language. I'm sure there are bugs though. I mean.
Can you compose multiple queries that live on separate strings so that the second one uses the output of the first one as input? Or do they always have to come from a file?
You can pipe to standard in, and then you can compose queries that way in the terminal. And there's also a wrapper around, so you can initiate the query command on the inside of an existing query as well. So I think you can do more or less what you want.
As you compile the queries, do you have any benchmarks, comparisons with JQ or something like that?
Mine is, I don't have any benchmarks, but I've compared text parsing to grepping, for instance, and mine is about 10 times slower, which is not great, but I mean, it could be far worse. I haven't done much optimization, so I don't really expect to beat any benchmarks.
So we saw the support operator in the filter. How does that work when you have I'm just wondering the semantics when you have the filter expression with 2 ors and 1 not or?
Yeah, it is well defined, but I can't explain it to you from memory. However, there is an option to output the compiled query so you can see the expression in the compiled query. And of course, and I've tried to document it more precisely in the documentation, but that's certainly one of the things that I'm not entirely happy with, and that well could be far better.
So some of the special like syntax with say the question marks to like use the or in the query, is that reader macros, or is that all done by just like parsing the symbols?
It parses the symbols for the most part. There are a couple of tiny reader manipulations, but they're quite primitive. So yeah.
Last question, given the timing, did you face any particularly difficult design decisions?
I don't know that I've really finished designing it, to be honest.